what is going on with my computer. Up there. Update failed. Oh, well. We don't. This is the chapter I was on before we. What's that? Yeah, let me just kind of jump through here and make sure I didn't miss anything, but most of this here we're going to skip. All right, we talked about functions right there. You know, as I recall, the last thing we ran into is that right there, we've gone through all this. This is what happens when I open a file. Okay, we have not talked about what slide am I on here? Okay, we have not talked about random number generators yet. That's what we have not. That there. We skipped through some of this right here, right there. Let me just kind of review a little bit about our basic thing that has to happen with functions. That they're right there. Is whenever I declare a function, right there, and when we look at our code, the first thing we're going to have is our include statements right there, right there. And then whatever it includes that we have. Actually, before that we have our comments. I should put comments right there. And then the next thing we're going to have is our function prototypes. And what a function prototype is that when I write a function, right there, and I'm just going to come back to this page right here, is I'm going to write a function. Let's say I call a function int, right there. This is a type function int, and I'm going to just simply say average, right? AVG, and I'm going to pass it int A, int B, int C, right there. And I'm going to have a local variable within the function, just call it int total, right there. Total is equal to A plus B plus C, and I'm just going to return total divided by 3. Right there, end of my function. That's my little function that just calculates the average of 3 numbers right there. Well, in the way that I normally organize programs, and the reason people do it this way, because it's a pain in the neck to keep track of the order in which we write our functions, we go back to our, and I need to come up with a new document that's doesn't have 600 pages in it, because I keep using the same document over and over again. But try to go to the previous page. Right there. And I guess, all right, well, I lost my previous page. Right there. So actually it may be at the top. Maybe be a reverse order. Okay, yeah. All right. So my function prototype here, I would include that. And your function prototype is actually just the title line of your function right there. So in this particular case, it would be int AVG, and then it receives 3 integers. And you don't have to put the name of the integer, the value, but just int, comma int, right there, like that there. So you need one of these for every function you write. That there is the title. And this is just called the prototype. And the reason you include this is because the compiler, when it goes through the first pass and it sees a call for that function, it needs to know what it looks like. That's there. So basically all this is just saying that I have a function later on in my code that's defined. It's called AVG, and it's going to returns an integer, and we pass it 3 integers right there. And we list one of these for every function we have. The order in which we list them doesn't make any difference right there. So, and typically our includes right here are typically math right there, for example. Is the only thing that's in math actually is a bunch of math.h is a bunch of function headers or prototypes right there. So that when I call these functions within my code, the compiler knows what they look like. The actual functions in the standard library are actually in the library and they're in binary form and you can't change them right there. So then, once we have our function prototypes, we may have any global variables right there. And we talked a little bit about global variables, and we'll talk a little bit more later today that they're so that they're. And then the first thing we're going to include is void main right there, and this is our main routine right there. And then after that we have our functions right there. So now this discussion, the reason for it is just simply to define what these function prototypes look like right there. And some of you have seen them before right there. So, all right, going back to my slideshow here, right there, right there. We have these function prototypes, and right up there. Now, every function should end with a line that says return. If you forget the line return, it doesn't make any difference. But if you're returning a variable, then a value, then you need to return and what the name. But there, an alternative method, and it's kind of awkward, is that I can use the name of the variable that they're going back to the function that I wrote. Here it is, right here. Instead of this last line, I could remove this last line, and I could say AVG is equal to total divided by 3, and leave the return line off that there. And because I named the name of the function is AVG, and I use that as a variable name instead of equal to total divided by 3, it will interpret that as return total divided by 3. The cleaner way is the return statement right there. So, right there, evaluates expression, returns a value. Right there. Some compilers issue errors, others issue warnings if you do not provide a return. Right there. Again, it depends on the compiler. The normal way is to use the return, but that there. But you have the option that there. Our function declaration, I define that there. Okay. And basically, the only thing the rest of this all says is that we could forget, you know, if the prototype doesn't match the function and doesn't match the calling routine, then you're going to get an error. So when I call AVG in my main program right here, when I call AVG, I'm going to say X is equal to AVG 157, and these could be variable names, but these have to be 3 integers. If I said AVG 15, it won't work because it needs to have that 3rd integer there. They have to match exactly right there. I'm not going to go through all these various data types. And you got unsigned long int, long int, all kinds of various ones out there. Our header files out there, we've been using them. This is just kind of the official discussion of them right there. IO stream is the one we've been using a lot in every program that allows us to use C in and C out. The IO manipulator allows us to do things such as look at mid character and set up our what thing I want to term the number of decimal points we want and things like that. There, C math contains all of our math libraries, so sine and cosine. Our standard CST library, conversions of numbers to text, it's convert standard library. Numbers to text, text to numbers, random numbers, all that stuff there. C time. Some people just include all of them. It doesn't hurt to just include them all. You shake your head as if you've had that.
No.
But
when we do a lot of the header, so when we want to do something like we don't need to go back to the header, write string, and
So again, you just do.
These are all.
Just include. You just include everything, and that way you don't have to that there. So some people just simply that there. I've actually seen some people just generate a file called headers, and just include headers, and then in that file would be just the list of all the headers right there. So that there. And as you can see, there's all kinds of various ones right there. That there, all kinds of different ones right there. So, and we're going through 5 pages of these right there. And that's why I'm saying a lot of people will just include them all. And I know some programmers, and again, this is work with C, they just generate a file and all it does is include this one, include, and they call it headers.h. And then they just, in every piece of code they write, they just say include headers.h right there. Because to be honest with you, I don't remember which functions are in which header. There's just too many to remember right there. So, but there, for sake of this class, you just need to include the ones that we're going to use. But in real life, most people just include a lot of them that there. Okay, this is the random number generator right there. There's an internal function called rand right there. And it's in the RAND library, which is convenient, the random number generator library right there. And in the CST standard library, there's also right there, the constant. See, this one's kind of interesting because you need to include both RAND and the CST library in order to use the random number generator function. And you also need to include time, C time, right there. So in this particular program that he's going to go through here, you basically have to include 3 different library header files for it. That's why it gets complicated, which ones you need, don't need, and that's that there. So the value of rand max is at least 32,767. It could be larger. I have no idea what it is with the C compiler we're using right there. I think it's the same as the one I'm just trying to think C or the Visual Studio, but it could be the same as if it uses the GNU C++ compiler, which it may be this much larger number right there. So that there, but again, so if rand truly produces integers at random, every number between 0 and rand max has an equal chance of being chosen each time rand is called. However, the pseudo number generator in Visual or in C whatever compiler is not truly random. It's quasi-random right there. There's a little algorithm they go through. It's too complex, and that's a math problem that there. If you want to know how it works, Maybe Dr. Aswana can tell you that there. I can't tell you how it works off the top of my head right there, how the random number generator works. That there. But this is, we're going to roll a dice right there. To roll a dice, we need a number between 1 and 6, right? Right there. Every dice that I've thrown, a standard dice, has 6 sides to it. There are some funky dice for some games I've seen that have got 5 sides and 4 sides or whatever that there. But if you go down to the local store and buy a dice for a standard board game like Monopoly, I don't know, has anybody ever heard the game Monopoly or Chance or anything like that? They've got 6 sides to them right there. So that there. So again, what we have is we use the rand function right there. It creates a number between, and don't tell me my battery's going dead already. I just started this class right there. It sure is. Well, we'll keep. It's warm and my battery's going dead. And I guess we're going to have class on Friday, even though I said we we're going to have class on Friday already, right there, because this one's going to end relatively quick. But because we don't really need to know what rand max is, other than it's a big number, but we want to use the mod function. The mod function is just simply the remainder after you do the division right there. And we just simply, if we want to have 6 numbers, we just use this there as our range right there. And then we want to shift it, we can add the value. So our random number right there is going to be, here's our, to throw a dice right there. 1 is the starting value plus rand, the function rand. Modulus 6, that's the range. We have 6 different numbers, 0 through 5, but we add 1 to it, so it becomes 1 through 6 right there. And it's divisible by 5. This is just to print it out. But this is the function the only thing you really need to know about random number generations right there. Now there's a couple other things, but notice that we have to include this particular function library right there in order to use rand right there. So I said something about a rand library, but it's actually CST lab right there, the standard library right there. And we include the IO stream, the IO max, because we're using the C in and C out, and we're setting the width of right there, right there. So again, we're using multiple libraries right there. And this is what you get if you throw a dice 20 times right there. So right there. Now, one of the things to keep in mind that if I throw 2 dice, the probability I don't have a random number between 2 and 12. I have 2 random numbers between 1 and 6 right there. And that's because 2 dice, the possibility of getting a 1, it means that I have to have a 1 and or a 2, you have to have a 1 and a 1. To get a 12, I have to have a 6 and a 6. But if I look at to get a 7, I have a whole bunch of possibilities. I have 1 and 6, 2 and 5, 3 and 4. I have 4 and 3, 5 and 2, and 1 and 6. So I have like 5 different possibilities right there, 4 or 5 different possibilities. So that's the largest number generated when I throw 2 dice. 6 is going to be a similar number of possibilities right there. So whenever you throw 2 dice, it's not the same as throwing 1 big dice with 12 sides right there. So you have to add the 2 of them together. So you can write a function called die right there, or dice right there. Int dice right there. We don't have to pass it anything. And dice right there, and int die 1, die 2 right there, and die 1 is equal to, and I'm just going to say 1 plus rand divide by 6, die 2 is equal to 1 plus rand modulus 6 right there, and return die 1 plus die 2, and the function right there. So this is what we would this is how we would throw 2 dice right there. So it's not that terrible right there. So again, each integer should appear at least 1,000,000 times. It simulates right there. Right there. So this is a function that's going to roll the dice 6,000,000 times. Good morning. And add up the frequency right there. And this is, by the way, the program of the day. Right there. Because I can turn off my computer and right there. Although this room, like I said, is now starting to get stuffy. Right there. And at the end, this is going to show the frequency of throwing a dice 6,000,000 times. Right there. So, right there. And you can see it's somewhat random. You know, the distribution is somewhat, you know, uniform right there. If you were to repeat this function right there and you throw 2 dice, you would see something different. Matter of fact, I would like for you to modify this between now and Friday and just turn in a paper copy of doing this with throwing 2 dice right there. Just a short little check right there. So in other words, for Friday, basically modify this program to where from here we go 2 to 12 right there. And you change this one right here, and you do like I did here, you do plus 1 plus rand right there, random number between, or you can do 2 of them right there, but this is again right there, and notice that we've done this within that function right there, int base is equal to, and then we did this face right there. So if you modify this particular program to simulate the throw of 2 dice right there, and see what this comes here right there. Again, you would modify this to 12, 2 to 12 right there. So right there, you've already got the result from throwing 1 dice 6,000,000 times. Now what happens if we throw 2 dice 6,000,000 times right there? So this is your key thing right there. So right there, and you could do it within a function, or you could do it like he's just did it right here within the, he did it within the for loop right there. The easiest thing is probably just copy this code right here and just make those 2 minor changes. Actually 3 changes. Change number 1 is you would have 2 dice thrown right here. Change number 2 is you change your switch statement from 1 to 6 to 2 to 12. And then change your C out to include frequencies 2 through 12 right there. And just to see that it's not a uniform right there. So I'm going to continue going until my battery goes dead there, and fortunately it's safe there. Okay, there. Now this kind of go through, and I'm not going to go through any of this stuff right here. Now we do need to do one other thing, is we need to seed our random number generator. If we don't seed our random number generator, then we don't necessarily get the same or different results each time. If we're dealing with a random number generator, we should not get the same series of random numbers every time. Now the seed is how you start the random number generator. It's a SRAN seed right there, random number generator, seed random number generator right there. Right there. And all it simply does is if I pass to ran a variable right there, this actually starts the random function at a known point right there. So if I want to, for example, generate a series of random numbers and get the same series every time, then I would give it a known seed. Normally what most people do is that they call a function called time right there, and time actually that there returns the current time in the number of seconds since January 1st, 1970 at midnight. That there, we don't care what it is, it's just going to return a number, and we have no idea what the number is. It's the number of seconds the computer's been on. That there's, or not since it's been on, since the, as I said, January 1st, 1970. It's just going to return a number, and then it just starts the random number generator at that number. That number is always going to be different, and it's actually not the real number of seconds because that particular variable is a long int or something like that, and it rolls over when it overflows, so that so it's a modulus whatever that there. But it's a number that's somewhat random right there, and you have to include the ctime function header for it, and all you do is simply this. Now I'm going to put this games with rules of craps. I'll be quite honest with you. I tend to use this for a final project question right there. Now, the final project question usually is you're going to play 1 million games of craps. What's your percentage of winning? That's there, and it's a simulation, and it's one that I use quite often for that right there. So probably look to see this rules of this game of chance craps again. Usually it might be on the midterm project or another project. I think I have one more, or it may be on the final project. But you'll actually do this particular one right there. Not now, but now just do the throwing the two dice. But the rules of you'll need that function for this. Rules of craps. And by the way, when I do the game of rules of craps, I don't do it to teach you how to gamble. I do it to teach the fact that you always lose if you gamble, right there. So if you gamble enough, you always lose, right there. And as I recall, craps usually comes up with about a 52% loss and 48% chance of winning. And there's a rule in statistics called the rule of large numbers. The more you do a random function that has a probability attached to it, the closer your final result is to the probability, the actual probability. So if I go into a casino and play 10 games of craps, I may end up winning some right there. I may actually walk away with more money than I walked out with that there. But if I play the game long enough, I'm always going to lose all my money right there. And I don't know, this is a Muslim country, and you're all good Muslims, right? So probably none of you have ever been in a casino, right? That there. Well, I wasn't born a Muslim, but I've been in plenty of casinos, and you've seen them on TV, though, right? You know what a casino looks like on television, right? That there, and they don't look like dull, dingy, nasty places. They don't look like your local mama coffee shop. They got bright lights, crystal chandeliers, fine glasses, thick carpets. They're very expensive places to maintain. And in order to maintain those, they don't have a little box like they have at the Shroud for the winners to donate part of their winnings to the casino on the way out. All those decorations and all that free alcohol and all these employees are paid for out of the people who lose money. So there's far more people that lose money in a casino than ever make money. So when you look at the game of craps and you run the simulation, you will see that you almost always lose money. But that's there. So again, they're showing right here. This is what happens when a player wins, loses. This is what happens when a player wins, right there. And you'll go right there. So that there. Okay, enumeration types right there. they use an enumerated type here called win, loss, or gain, right there. Where is it? Right here. Status, right there. That particular, that simply says that particular, we declared a new type, right there. Status is a new type, and it can take on the value of win, continue, won, or loss. An enumerated type is a type which we define. You can define an enumerated type such as days of the week, and it can only take on the values Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. We can do an enumerated type called months, right there. And months can take on the value January, February, March, blah, 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 right there. But this is a type, and then we can declare a variable there, status game. This is declaring a variable called game status, and we're saying it's equal to continue right there. Right there. So the variable name is game status. The type is of type status. It gets very confusing when you start using a lot of enumerated types that there. I would encourage at this stage not to use a lot of them that there, but just so that you've seen what they are. But of course, if you're going to be using this code exactly right there, and you can use this code exactly that there, the only difference is you wouldn't print everything out if you're going to play a million games right there. You're just simply going to, or 6 million, you're just going to keep track of the statistics. You're going to play the million games like you're doing rolling the 6 million dice. Only difference is that you do that there, and now I'm getting warm right there. So there. Okay, this is showing months of the year, months right there, right there. So again, introducing at there, and I'll leave that for you to read since you'll be at there. Random number generations right there. I'm not going to go through that in great detail. Rolling the dice, we've already talked about that there. Again, we're looking at the fact that we have to include now 5 or 4 different include statements right there. As I said, as your programs get more complex, you do more and more and more includes, so it's not unusual to just include everything right there. So random int right there. See, this is now calling a function called random int right there. And where is it? Right there. Cast right there. Oh, okay. This is just right there. I'm going to skip that right there. Okay. We'll come back to scope. Scope basically simply says that if you declare a variable within a for loop, it's only known within the for loop. If you declare it within a function, it's only known within the function. If you declare it outside of a function, it's known everywhere. That's called a global variable. If you declare it within main, it's only within main, because main's like any other function right there. So that there. I'm not going to talk about the classes so much right there, just the basic scope. Local variables are declared within functions, function parameters. They're right there created when enters the block, and when they exist while the block is active. When you exit the block, they go away. And a block, for most cases, in my viewpoint, is a function. However, other blocks, such as a for next loop, you can have functions there. You know, that's what he's done in this particular program right here. If we go back to it right here, he declares it's way back here. No. Here he declared a variable called face within this for loop, and that for loop is a block right there. So once I leave that for loop, face does not exist right there. Right there. Good programming techniques, they tell you to keep your scopes as small as possible. That's not always possible, that there. Right there. Some people will say you cannot use global variables. I say that you should avoid them, but you can. I'm not going to get any external and static. Right there. Block scope, function scope, global scope, function prototype scope. These are the types of scopes you can have. Block scope is one, say, in a for next loop, for loop. A function is within a single function. Right there. Global means that it's declared outside any functions known anywhere. And the function prototype scope, I've never used that there. So, that's there. And there's one more thing left in this chapter, and we'll cover it on Friday, and then we'll move on to arrays. I've got about 2 to 3 topics I need to cover before I switch to MATLAB. So I'm trying to rush through the things that I consider real important in the C programming. We've lost a lot of time between holidays, my headaches getting in the way, and me skipping Fridays because nobody likes to be here on Fridays, right? That there. So, but this Friday we will meet, and we'll probably meet the next couple Fridays till we get caught up, right there. So, that there. The only thing left in this that I'm covering out of this chapter, most of this here I'm going to skip, is on Friday I'm going to cover recursion. Right there. And recursion, function overloading, I'm not going to cover in this class. That's an advanced topic right there. Function prototype, templates we won't cover. Recursion is the next thing that I'm going to talk about. And I'm probably going to spend about half an hour on that and then move on to arrays right there. So I have approximately, now I had my battery on the charger right here, but I have 9% of my battery left. It says 15 minutes, but yeah, actually I started off with 20% and I ran for almost an hour, or 45 minutes to an hour that they're recording, so I guess that's probably about right. Well, this was a relatively short class. Part of it's because of the heat in this room, and because I could go up and get my charger.